Here we see a rough sketch of the graph that was given in the book. I've included just enough information to do what we have to do. So we're going to find the equations of each of these line segments. So for the first one, which I'm going to draw here in green, let's go ahead and find the slope between these 2 points. And so to get the slope, we have y2 minus y1, 39.2 minus 42.8, divided by x2 minus x1, 4 minus 0. And let's simplify that. And we end up with negative 0.9. And we can see from this point here that the y-intercept for that line is at 42.8. So that line has equation y equals negative 0.9x plus 42.8. Okay, now for the second segment, which I'm going to draw here in red. Let's find the slope between those 2 points. So we have the slope equals y2 minus y1, 32.7 minus 39.2, divided by x2 minus x1, 8 minus 4. And for that, we get negative 1.625. We're also going to have to find the y-intercept for that line. And so what we can do is use point-slope form. So point-slope form is y minus y1 equals m times x minus x1, where we use one of our 2 points as x1, y1. So suppose I use 32.7 as my y1. We have our slope. And suppose I use 8 as my x1. So when we work that out, we end up with y equals negative 1.625 times x plus 45.7. So that's the equation of that line. So now we want to put these together into a piecewise definition. Okay, so we could call this f of x, and we have 2 pieces. And one of the pieces has equation y equals negative 0.9x plus 42.8. And the domain for that piece is 0 is less than or equal to x is less than or equal to 4. And we can always write the word if in front of that if we'd like to. And then the second piece has equation y equals negative 1.625x plus 45.7. And the domain of that piece is 4 is less than x is less than or equal to 8. I just chose to put the equal to on the 4 for the first piece and not for the second piece because typically you just choose to put it in one place or the other, but not both. So there we have our piecewise definition.